So it's a good time if anyone has any questions. About the class?
I thought the class started at 10:30.
Oh, okay, so I'm going to ask you to repeat your question. I'm going to tell you something. I'm actually, you might not notice, but I'm a really old guy, and I'm probably going to be dead soon. And that means my hearing is a little funny. Now, gentleman in the red there, could you just in a normal tone say your name? Carlos? Okay, see, I can hear that fine. But if other people are kind of, and someone, you know, is talking, and if you're a female and you have a higher pitched voice, I'm going to have a hard time hearing you. So you'll know that because I'm going to go like that, and then you just repeat what you were going to say. So if you repeat the question.
I thought the class started at 10:30.
You thought?
It's 10:36.
Oh my gosh. Okay, good. I have smart students. Class is started. All right. Is anybody not here? Did anybody not get to sign this? Okay.
Yeah.
Please pass this around for everybody. Again, if you're not on there, now I'm late. All right. So, anyone who walked in while I was explaining this, my second class is 11:45. You get old and you get stupid.
Wait, you thought we were here an hour early?
No, I have another class at 11:45,
okay.
so I guess 10:30, I get my brain can switch to 45. So when you deal with numbers too much, they overwhelm you.
Math is hard.
Okay, so I have this website. Again, all you need to know to get there is how to spell my last name. And you can see here, I'll put, well, if you got the email and you did the assignment, you just, you listened to me here for 40 minutes or so. Did anyone not get that email and not do that? Okay, it's there.
I got your email, I think, like today about that.
Yeah, it was my fault that I wasn't here. I apologize. This is cool. There won't be any exams real soon. The next class, you can ask me about that. No problem. Okay, so that's, I'll try and, put videos up so you can look again, and if I do something really embarrassing, you can, put it on YouTube and make
The fact that
money.
you had a blooper reel in the first I like this guy already.
I will try to always have the assignment, whatever the current assignment is going to be. You can see here, there's an assignment for Monday. In the past, I've tried to be really flexible about homework, but I'm going to have a grader here, so I don't think I can just have you turn in your homework 3 weeks late and give it to the grader. Homework is always kind of a mixed bag. One strategy would be I would just say, here's some problems, and go do them and ask questions. And some students would go ahead and do that, and they get everything out of it. And then some students would go, I got better things to do. I have, video games to play, and they wouldn't do very well. On the other hand, I can say half your grade is the homework, and then I'd have to worry about the unfortunate time demands that people have, and they might think, well, I'll just have my friends, I'll copy my friend's homework, and then you don't get anything out of it, and I'm sad. So we're in the middle. I give you about 10% for your homework. You need to do it if you want to get an A. Everyone wants an A, right? So please do the homework. I don't mind you working together. I don't want you copying somebody's homework. I want you to at least write it down and understand it, or if you don't understand it, bring in questions. The way the graders seem to work here is we pick out not randomly, but we pick out some particular problems that they're going to go through thoroughly, and they're going to check that you did the rest, which, again, feels a little funny. I think you people, you're adults now, and we want to treat you that way, so why am I, like, asking you to do something we're not going to check? But that's the way they do it. Some of you I know probably aren't adults yet, but we're going to get you there, right? So this is the assignment for Monday. Do your best with it. I think that's it. Everyone knows you need a textbook, which can be electronic, or you can rent it, apparently. There are going to be 2 midterm exams and a final. I don't know. When we make part of the assignment, just go through the syllabus, bring in questions if you have any about it. Ask questions now, yes.
So your attendance policy is basically you need to show up to do well, obviously.
I want you to show up
Right.
every day you can. If let's just say, for granted, that you don't belong in this class. You know everything, and you're stuck in it.
Mm-hmm.
And maybe you're not going to show up at every class, but you're going to get an A on everything. If you're going to do that, come talk to me about that before you do it. I would understand, I already know functions, I can't encourage you not to come to class, you understand? That's where we do stuff. But I understand that everybody here has a different story and a different experience in math. Some of you, some of you it was hard, right? If it was really easy, there's a good chance you aren't here, or maybe you were good at it, but you kind of messed around in high school, and now you're ready to get serious, but you know this stuff. Everybody has a different story. So I try and be flexible with people, but I don't want you to think that this is an easy class. We're really going to get into we're going to do what we did in high school in a semester, what you did in a year. So it's going to move fast. If you've had trouble before in math, I have office hours. You can come and talk to me, but don't expect this to be easy. You're going to have to put in time. You're going to have to do the homework. Okay, that's the pep talk, right? You're ready for the football game now, right? So, all right. Before I get started, you can raise your hand anytime and ask questions, but anything so far?
And so, like, when we do the homework, do you care if we do it on like graph paper or notebook paper?
I don't. Legibility is appreciated. I will talk to the graders, see if they have any, inclination one way or another. But personally, I don't care as long as I can read it. The better organized, the easier it is for the grader, and I'll probably do it a little too. Draw boxes around your work for the problem. Put your name on it. That's always good. There's always somebody who doesn't see the importance of that. But, okay. Other questions?
Are you going to put anything on Canvas?
On
Canvas,
if I do, I have to learn about it. So if I start using Canvas, I will make a big deal about it in class. Okay. As of right now, if you miss a class, check my website, see what you missed, see what the assignment is. Or email me if you have any questions. I know I mistakenly sent everybody an email from my personal email. I don't mind you having it, but officially you should write to me usfca.edu, right? That's the official place to send emails. So they can check up on me there to check up on you. Okay. Next big subject. If you didn't see the video, this might be a little confusing, but you'll catch up. Are there any questions on that video, on the lecture? It was about sets, mostly. Anybody find it difficult? Or find it really easy? I'm not going to know where you guys are until you give me that kind of feedback. Did anybody look at the video? Yeah, okay, all right. Sets are, mostly about the language we're going to be using. And we're going on, we're going to be doing more advanced math than you've probably done, some of you have done before. This is pre-calculus, it's in preparation for calculus, so while we do a kind of an eclectic group of things, everything we do you will find useful in calculus if that's where you're going. If not, in your other classes, if you do stats, you're going to need to know functions. Trigonometry is just a great subject if you don't know it already. Okay. So everybody's okay on the intervals and absolute values and so forth? All right. One more side note about the first few classes. It's really, we're going to do review of things that may have done in algebra, advanced algebra, and maybe a little geometry. And this is going to go really fast. So please stop me if you have any questions. If this is really simple, it's way under your head instead of over your head, I apologize. It's just a course, and we're trying to get everybody to the same place. So when we start doing new material, everybody's on board. All right? No, I think we'll leave it. Also, just some, again, some basic things about the class. In high school, you want to use the bathroom, and you go use the bathroom. You're adults now. If you need to use the bathroom, you just go. If you need to leave class early, just don't be disruptive. If you get here late, come on in, just quiet, see what's going on. Hopefully you won't be getting phone calls, but if there's some kind of emergency going on in your family or something and you need to, okay, maybe put it on vibrate, and if you need to take a call, just take it outside, right? Just try not to just think of everyone else here, try not to disrupt the class. So, other than that, do whatever you need to do, right? Okay. Subject for today. Leave that out. Kind of doing this classroom, so I don't know what my boundaries are yet. I'll learn. We're going to learn about exponents. And let's start with just the definition of an exponent. If I have some number a, and exponent n, what does that mean, right? It just means this is a times a times a n times, right? We're talking about n as a integer, so that makes sense. At least if n is, I guess I should start here, talking n greater than 0. We'll get to n0 and less than 0 in a bit. So, so we have a rule about this. If we have some a to the n times some a to the m, you probably know this is just a to the n plus m. Maybe you know that, you understand why that is, or maybe it's just a formula. I always, you know, sometimes in math, it's just good enough to know the formula, right? Like area of the circle, what's the area of the circle? Everyone knows that, right?
Square.
Got a hand? Somebody? Just somebody just, what is it? What's the area of a circle?
Pi r squared.
Pi r squared. Everybody knows that, right?
Wasn't
Well,
sure.
it's probably enough to just know that. If I said, why is that? Well, we could go over that. It's always better to know why, but sometimes it's good enough. So this is good enough, but let's think about why that is for just a second. So a to the n is just a times a times a times a n times a times a times a times a m times. But how many have I got? I've got n and m, so n plus m. So that's just going to be a to the n plus m. All right. That's just a simple example. If you knew that already and it's obvious. The edge of my blackboard here. Similarly, if I had a to the n over a to the m, where for the moment n is greater than m, so it's the same thing, right? A times a times a, n times over a times a times a, m times. Well, n is greater than m, right? So m of those times, right? This is just a over a times a over a times a over a. And then we're still left with how many? There's m of these, right? There's m on the bottom. We used those up. We used m on the top. So how many do we have left? N minus m, right? But what's a over a? What's that got to be? 1. We don't care about ones, right? Multiply by 1. We're just going to get. So now we're going to get that's a to the n minus m. So now we have a formula, but we know why we have that formula. Paying attention really close. I'm going to have to turn this off. If I turn this off, I have a bigger screen, don't I? Bigger blackboard. Okay, good. There's something I haven't said, and when you go on in math, it's perfectly okay to say, Professor, wait a minute. There's something wrong here. What's wrong here? Where did this go wrong? And I haven't kept us out of that. Mud puddle. Anyone know? Yes?
Like the exponents and fraction?
We're going to get to that. For now, oh, I didn't write it down, but I'm thinking of n as an integer. But,
Oh, okay.
but you're thinking along the right lines. There's something else wrong with it. What about a? You got a in the denominator here. Is that going to work all the time, no matter what a is?
No,
No, it's not going to work if,
it's 0.
0.
yeah. So I really should say a not equal to 0. All right, now we're okay. Now it's going to work. Okay. All right, let's use this and now, of course, we know what that has to be, right? A is not 0, so a to the n over a to the n, something over itself is just 1, right? But let's use our formula here for a second and see what we come up with. That's a to the n minus n, which is just a to the 0. Now I suspect a lot of you, most of you know that a to the 0 is 1, but you know, maybe you didn't think about that when you can use this formula. That's really neat. A can be anything. It can be negative 0.03 or the square root of 2. You raise it to the 0 power, you always get 1. All right, I'm going to take that a little further. Let's look at 1 over a to the n. Well, we know that's a to the 0 over a to the n. And again, using our formula, we can see that that's going to be a to the 0 minus n. Well, what's 0 minus n? It's negative n, right? So now we have, you know, yet another formula. 1 over a to the n is just a to the minus n. If you're observant, you'll notice it doesn't really matter what n is either. N could be negative or positive. So, you know, if I say, what's 1 over 3 to the minus 2? Might be a little confusing, but we can see by this formula that's just 3 squared, which we know is 9. Okay. Any questions so far? This is pretty basic stuff, right? Okay. All right, let's take a look at what a to the n raised to the m is. Again, I'm assuming n and m are greater than 0 here. Well, we're gonna kind of look at this a little, you know, in depth, the way we did on the first example. Now we know a to the n is a times a times a n times. Okay? That's what this is. But we're raising this to the m power. That means we're going to repeat it m times, right? A times a times a n times. And we're going to keep doing this this whole thing we do m times. So let's think about this. How many a's do we have? Well, we've got n times I'm sorry, we have n times plus n times plus n times plus n times m times. Well, that's just n times m, right? So that's just going to be a n m. All right, that's a nice little formula. Right. Let's look at this construction. Now again, we have an A and a B. They're not 0. We're going to raise that to the n. And, okay, that's A times B times A times B times A times B. How many times? N times. But of course I can rearrange these. This is multiplication. We have we're going to look at a little later, the associative law and the commutative law. I can move these around. So I can move all the a's over here. And I'll have how many n of them. And I can move the b's over here. I'll have n of those. Well, this is just a to the n, and this is just b to the n. So we can see a times b to the n is just a to the n, b to the n. All right, let me just take a deep breath here for a second. What are we doing? We're just learning all these different rules for exponents. Now, again, when we're all done, we'll have a list, and you might want to memorize the list. Or you might want to think about why each of these items is the way it is. In math, exercise that part of your brain more. And why is it that way? You're going to find it eventually will become easier. Harder at first, easier later. All right. Let's look at another one. Going flying like a cat. Look at a over b to the n. Well, this is just a over b times a over b, a over b, n times. But we know we can rearrange this, right? We can just put all the a's on top. And all the b's on the bottom. Each of these is still n times. And so this just becomes a to the n, b to the n. Now, again, I've been assuming n is positive here. Keeping that the case, though, let's say, what would this be? Well, we know from this formula, this is just going to be a to the minus n over b to the minus n. And from a previous formula we looked at, we know this is just 1 over a to the n, and this is just 1 over b to the n. Okay. Not a tricky question. How am I going to simplify this?
You take the reciprocal of the bottom.
Very well stated. You can see who that was. There you go. Did you hear what you said? You multiply by the reciprocal of the denominator, right? Everyone knows what a reciprocal is, right? It's just 1 over, or 1 over this, and we flip it around. But to keep everything nice, we have to multiply by the reciprocal over the reciprocal. That's 1. That doesn't change it. On the bottom, we get b to the n over b to the n. That's just 1. On the top, we have b to the n over a to the n. So we can see that a over b to the minus n is just b to the n over a to the n. Okay, just one more little rule we're going to look at. Again, something, memorize it, or you can think about, how did we get there? We're going to look at a to the minus n over b to the minus m. Well, okay, using that formula, this is 1 over a to the n. Likewise, this is 1 over b to the m. We're going to use the same strategy with the reciprocal. Multiply by b to the m over 1. This is just going to be 1 on the bottom. So we end up with b to the m over a to the n. Quick summary before we go on. A to the n, a to the m, a to the n plus m. One over a to the n. Am I doing these in the right order? No. I'm doing it in the right order. A to the n over a to the m is a to the n minus m. Let's get this right. A is not equal to 0, right? I'll just throw this in. A to the 0 is equal to 1. Does anyone know what 0 to the 0 is? Is it?
Nothing? Can't be calculated.
I mean, said A is not 0. This is true if A is not 0. Do you think this is 1? Anybody remember their teacher telling them something about A to the 0? We're not going to do it now. This is undefined. Watch out for it. It's just like this. Don't do it. Stay away from that. 1 over a to the n is a to the minus n. Or you could put the minus here and take it away there. A to the m, n raised to the m power is a a to the n m. Go this way, but when you see this, you can go this way too. Sometimes comes in useful. AB to the n is a to the n, b to the n. Number 6, number 7. A over b to the n is a to the n over b to the n. All right. A over b to the minus n is b over a to the n. Therefore, b to the n over a to the n. And finally, a to the minus n over b to the minus m is b to the m over a to the n. I have a question. I just want to know, are people comfortable with this idea? When I write down a letter like A or N, I'm talking about a constant. I can put any number in there, but it's not a variable like when we use X and Y. So A and N and M are just some number. Could be any old number, unless I tell you like it's not 0. And usually when I say N or M, I mean an integer, right? Not a fractional number or something exotic like pi, right? They could be pi, right? All right. Let's do an example. You know, this is very abstract, nothing like seeing a real example like you might get on your homework. Normally I'd be inclined to do more examples, but again, this should be review. I'm going to take one from the book. So, now I'm using X and Y's. Well, that's okay. We could plug in some value like an A or a B or a 5 or a 6. It would work fine. Cubed times y cubed x z to the 4th. And I want you to, but you know, that's fine. There's nothing wrong with that. But I want you to simplify it. Okay. Often when you're doing math problems like this, what does he mean by simplify? Well, it's either obvious or it's not. If it's not, you know, you have to think about it a bit. But I think in this case it would be straightforward. For this kind of problem, it's a good idea to try and get all the x's together and the y's together and the z's together. So how are we going to do that? Well, first let's expand this. That's x to the 3rd. That's y to the 3rd. And same thing here, right? This is y to the 3rd, x to the 4th, and z to the 4th. Okay, this is a little more trouble here. But we have, there it is, a and b. Right? X cubed could be like a, and y cubed could be like a, and x could be like b. So I've got y cubed to the 4th times x to the 4th. I have to rewrite everything, don't I? Math can be a lot of work. Let's keep this here. Y cubed to the 4th, x to the 4th. Z to the 4th is still fine. Oh, it's so messy. Y cubed to the 4th, x to the 4th. Okay. We have a formula to deal with this. this, that just becomes y to the 3 times 4, right, or 12. Anyway, symbol in the wrong place. X to the 4th, c to the 4th. And now I'm kind of ready to clean up. I've got an x cubed here and an x to the 4th here. X to the 3 times x to the 4 is just x to the 3 plus 4, or 7. That's on the top. I've got my y to the 12th on top, but y to the 3rd on the bottom. That's just 12 minus 3, right? So that's y to the 9th. And what's left? Oh, z to the 4th. Okay. Anything else I can do to simplify that? I don't think so. Yes?
Could you do y to the 3rd squared?
Y to the 3rd squared.
No.
Oh, but then, why? Oh, I'm sorry. Oh. So x to the 7th, y to the 3rd, 3 squared. If you like that sort of thing, there's nothing wrong with that. Is it simpler? It's kind of an aesthetic, right? I mean, I kind of agree with you. It's like 3 squared, that's kind of a more compacted way of writing 9. It tells me something about it. But it's not wrong. The book, because I know how authors of books, they would think that's the right answer and that's too complicated. But I have no problem with that. So. Okay, any questions about exponents? Yes?
In our final answer, do you want us to keep all our exponents positive?
Okay. So your question is kind of, how's this?
Yeah.
That's fine. Again, you know, there's certain aesthetics. You know what I mean by aesthetic? It's not really right or wrong. It's just it looks pretty. We're gonna get another one real soon. I'll tell you about. They would like, oh, we don't like negatives. Negatives are difficult. No, they're not. I wouldn't have any problem with this. Now, remember, we're learning math, but we're learning math either to do more math, or we're learning math to do physics or economics. So let's say you're doing some formula for economics, and now you're going to have to plug numbers in. Is it easier to plug it in with the minus or harder? I don't think so. So in the end, it's, you know, what are you going to do with it? You may have had a teacher who said, I want the answer this way, and if it, you know, you're smart, you look at it, it's the same thing, but they want it some other way. I'm not going to be that way. This is, you know, we're getting to the real world where this is the same as that, and so, okay, fine with me. Questions that say simplify too, I don't like them because, you know, it's not always obvious what simpler is. Simpler to you might be different for me, but certainly we've gotten rid of, you know, we brought the x's together, we brought the y's together, so it kind of aesthetically a little better. All right. It's going slower than I thought. Next thing I want to talk about, I want to take what we've done and extend it a little. to say, all right, you know, we were saying n was an integer. Everybody got that, you know, I might use this symbol, z, to mean integers, and I might use this symbol, say, member of the set of integers. Well, now we're going to change this, and now we're going to say n can be a member of the fractions. So we want to know, what does a fraction exponent mean? So, let's start with this guy, 5 to the 1/2. What is 5 to the 1/2? Well, let's just give it a name. Call it x. And I think we can get rid of that fraction if we square both sides. Right? So I'm going to square this side, and then 5 to the 1/2 times 5 to the 1/2. And we're not going to prove this rigorously in this class, but let's hope and pray that our exponent rule works here, right? So this just has to be 5 to the 1/2 plus 1/2, 5 to the 1, which is just 5. Okay, that gives us a hint. X squared is 5. Well, we know how to handle that, right? What does x have to be equal to then? It has to be the square root of 5. This is like the key to jumping from integers to fractions in your head. You don't have to suddenly understand every fraction. You just have to kind of see, oh, that's how we get here. That's why 5.5 is the square root of 5. All right. Let's push this just a little further. Let's say 7 to the 1/3. Okay. So if x is 7 to the 1/3, I think we're going to do the same kind of thing. We're going to say x times x times x. That's like x cubed. That's 7 to the 1/3 times 7 to the 1/3 and 7 to the 1/3. Well, using our formula, that's got to be 7 to the 1. So if x cubed is 7, what is x? X is the cube root of 7. So that's what 7 to the 1/3 means. It means cube root of 7. So, all right, so we seem to have some kind of formula here. A to the 1/n is the nth root of a. Actually, a could be 0 here, but I don't really want it to be. And n is just, it's a member of the positive integers. That's the natural numbers. Okay, maybe we could, make things a little fancier here. We could say it's a to the n over m. Well, we know from our formula that that's just, let's see, n times 1 over m. And again, hope and pray our formula still works with fractions. So that's just a to the 1 over m raised to the n. We know what this is. That's the mth root of a. is to the end. Okay, but we could have done it another way, right? We could have said this is a to the n to the 1 over m. So it could also just as well be a to the n, the mth root. So we have some flexibility here in interpreting this. It has to be the same value, right? You plug it into your calculator, you have to get the same thing unless there's something wrong with your calculator. Okay. There are a few more properties that are analogous to the integer exponent. I'm just gonna write some of them down. You might need some of them for your homework. Nth root of AB, that's just the nth root of A times the nth root of B. The nth root of A over B, just the nth root of A over nth root of B. The nth root of the nth root of A is just the nth root of A. This is just kind of like with the exponents, right? A to the n raised to the m, it's just A multiply n times m. So you can multiply these, if you think of them as fractions, you just multiply the fractions and you end up back here. I think that's enough for now. I didn't get to scientific notation, so if there's any problems in the homework on scientific notation, don't feel obligated to do them. We'll talk about scientific notation on Monday.
Me too.
I'm here for about 10 minutes if you have issues, questions, problems. Yes?